In this video, we'll look over some topics to prep for the standardized math tests, such as the MCA, ACT, and SAT. In question number 1, it asks, what's the equation of a line that includes the point 4, -3, and has a slope of -2? Well, right off the bat, I can tell that option D doesn't have the correct slope. That slope is +2, so I'm going to eliminate it. And it looks like I need to write an equation in slope-intercept form. I'm going to start with point-slope form, which looks like this, where x1, y1 is a point, and m is our slope. So our slope is -2, and then we have the point 4, -3. So x1 is going to be 4, y1 is going to be -3. That gives me y plus 3 is equal to -2 times x minus 4. If I distribute the -2, I get y plus 3 is equal to -2x plus 8. Make sure you multiply a negative times a negative is a positive. And then I'm going to subtract 3 from both sides. I get y is equal to -2x plus 5, which is option C. The next one says, are the two figures shown below congruent? Why or why not? Okay, so looking at what we have here, I see that angle A is congruent to angle E. Angle B is congruent to angle D. And angle C is congruent to angle F. But now these are all angles. Angle is not a similarity proof. Okay, this side CB, which is between the green and the blue, is congruent to DF, which is again between green and blue. Then I have the next pair, side AC, which is between red and blue, is congruent to EF, which is between red and blue. And then we have that third side, AB, between red and green, congruent to DF, between red and green. So it looks like these are congruent triangles. So let's read through our options. It says the two figures are congruent because the corresponding angles are congruent. Well, although that's true, angle is not enough to prove. The two figures are congruent because both the corresponding sides and the corresponding angles are congruent. That's feeling good so far, but let's read through the others. The two figures are incongruent because the corresponding angles are different. Well, that's not true. And then it says that the two figures are incongruent because the corresponding sides have different lengths. Well, that's not true either, so I'm going with option B. Question number 3 is about order of operations. Which order of operations should be used to simplify the following? Well, we use PEMDAS for order of operations. So we'd start with parentheses. In the parentheses, we have subtraction. So I'm going to eliminate options B and C because I need to start with parentheses. Then we would go to exponents. We don't have any exponents. So next up would be multiply and divide, and we need to do that left to right. So I see divide first, and then I see multiply, so that's going to be option D. Last step would be the addition, which follows in option D as well. Question number 4 says an arrow is shot upward with an initial velocity of 128 feet per second. The height of the arrow is a function of time in seconds since the arrow left the ground and can be expressed by this equation. H is equal to 128t minus 16t squared. When will the arrow be at a height of 240 feet? So I know my height is 240 and I want to know the time. So I'm going to plug in 240 for H and set that equal to 128t minus 16t squared. Now this is a quadratic, and I know that to solve quadratics, I need to set this equation equal to 0. So I'm going to move everything to the left. So I'm going to subtract 128t, and I'm going to add 16t squared, and I get this. 16t squared minus 128t plus 240 is equal to 0. Now, I recognize that these numbers, 16, 128, and 240, all have something in common. They at least have a 2 in common, but I'm going to try to see if I can find another common factor. I'm going to see if by chance they're all divisible by 16. So in a calculator, I'm going to type in 128 divided by 16, and I'm going to type in 240 divided by 16, and I see that they are all divisible by 16. So I'm going to divide everything by 16, and that's okay as long as I divide the right hand side by 16, and 0 divided by anything is 0, so that's good. So 16 divided by 16 is 1, so that's 1t squared. Negative 128 divided by 16 is negative 8, so that's minus 8t. And then 240 divided by 16 is 15, so that's plus 15. Hey, solving quadratics, we can solve by factoring, or we can solve with the quadratic formula. I always like to factor if possible. So here I have my unfoil shortcut. I'm going to see if I can find two numbers that multiply to positive 15 and add to negative 8. I believe negative 3 and negative 5 are going to work, which means this factors into t minus 3 times t minus 5. Now that we've factored, we can use the zero product property, setting each of those factors equal to 0 and then solving for t. I get 3 and 5, which is option A. Another option for solving this that probably would have been more time efficient would be plugging in these options. So if I had plugged in 3 into this equation, I could have seen if that height was 240, same thing with 5, and I would have seen that the height is 240. If I had plugged in t equals 8, I would have seen that the height was not equal to 240. All right, next up we have a question about proportions. It says a recipe for 32 ounces of lemonade calls for 4 ounces of lemon juice. So that's going to be a proportion. I'm going to put 4 ounces of lemon juice over 32 ounces of lemonade. Then it says Janet wants to make 120 ounces of lemonade. We need to figure out how much lemon juice she needs. So I'm going to set up my proportion here with a ratio that has the same value. So I did juice over lemonade, and she has 120 ounces of lemonade. We need to figure out how much lemon juice. So my proportion looks like option D. Question number 6 says, consider the following equations. The first function is 3x plus 2. The second function is 3x minus 7. Which of the following statements is true concerning the graph of these equations? So I see that they're both lines, and I notice that they have the same slope, but different y-intercepts. So if they have the same slope, they're going to be parallel. It says the graphs of the equations are lines that are perpendicular. That's not true, they're parallel. Then it says the graph of the line represented by this first equation, 3x plus 2, always remains above the x-axis, while the graph represented by the second line always remains below the x-axis. Well, that's not true. Just because my y-intercept is positive 2, right, and my slope is positive, doesn't mean it's going to stay positive. If I go to the left of that graph, eventually I'm going to hit the x-axis and hit the region below. So that's not going to be true. C says the graphs of the equations are lines that are parallel to each other but have different y-intercepts. I know that's for sure true. I'm going to check that last one though. The graphs of the lines intersect each other at the point 2, negative 7. Well, let's try that. I'm going to think about this first line, y equals 3x plus 2, and I'm going to see if that's a point on our line. I'm going to plug in this x value and see if I get negative 7. Y is equal to 3 times 2 plus 2. That's 6 plus 2, which is 8. So that point isn't on the first line at all. So I'm going to cross that off and keep my answer as C. Question number 7 is a word problem. It says the width of a rectangle is 2 units less than the length. So the length compared to the width. The width is equal to the length minus 2. 2 units less than the length. If L represents the length, which of these represents the area? Well, the area is the length times the width. So that's going to be L times L minus 2, which is option D. Question number 8. The number of feet any object will fall in a number of seconds is found by this formula. And then it gives us some variables. S is the number of feet the object will fall, T is the number of seconds, and then G is a constant, 32 feet per second squared. That has to do with gravity. If an object is dropped from the airplane, how far will it fall in 10 seconds? So we know the time is 10. We need to figure out how far it's going to fall. So I'm going to plug 10 into that equation. S is equal to 1/2 G, which it says is 32, times 10 squared. Well, half of 32 is 16. 10 squared is 100. If I take 16 times 100, I get 1,600, which is option B. Next up, question number 9 asks where the y-intercept is for this line. 3x squared plus 2y plus 8 equals 0. Well, I know that for every y-intercept, the x-coordinate is 0. No matter where I cross that y-axis, x is going to be equal to 0. So I'm going to go ahead and plug in 0 for x and solve for y. So that's 3 times 0 squared plus 2y plus 8 equals 0. Well, 0 squared is 0, so I have 3 times 0 plus 2y plus 8 equals 0. And 3 times 0 is still 0, so I get 0 plus 2y plus 8 is equal to 0. I'm going to subtract 8 from both sides. 2y is equal to -8. And if I divide by 2, I get my y-intercept of -4. Okay, x is 0, y is -4, so make sure that 0 comes first. And I have option C. Next question asks us to solve a quadratic. Solve a squared plus 5a minus 14 equals 0 for a. Okay, solving a quadratic can be done by factoring, which is my preference, or with quadratic formula. I'm going to think of those a's as x's. If that's helpful to you too, swap out a for x, and now we're solving for x. So this is an unfoiling problem. I'm going to look for two numbers that multiply to the end and add to the middle. It's going to be +7 and -2. That factors into x plus 7 times x minus 2. And then I get to use the zero product property, setting each of those factors equal to 0, and then solving. I get -7 and +2, which is option A.